Alright guys, welcome back. We're going to be solving another question from the dynamics and from the Meriam textbook. And we have this question where during a brake test, the rear engine car stopped from an initial speed of 100 km per hour in a distance of 50 meters. If it's known that the all four wheels of this car, which looks like a Porsche, contribute equally to the braking force, we need to determine the braking force F at each wheel. So we are looking for the force in each wheel, and we have four wheels in total. So 4F from all of these wheels, and we can assume a constant acceleration for the 1500 kilogram car. So if you look at this figure, we see that we have initial velocity and we have the velocity at the end of these 50 meters. So if we go with our formula, v squared minus v0 squared is equal to 2a times the distance that this car is traveling, which is basically 50 meters. So we can call it s minus s0, and let's just put our x-axis here, and this is going to be our 0. So we consider s0 0, and our s would be 50 meters. So the velocity at the end basically is the v2 that we have in here. So 0 squared negative 100 kilometer per hour. And if you look at it, we have kilometer per hour, and other distances that we have is in meters. So we can just do a unit conversion for this, and we know 1 kilometer per hour if you want to just report it as meter per second. So let's just do a unit conversion for the kilometer first. So meter kilometer, we know 1 meter is 1000 meters, so that way we can get rid of the kilometer. And we know also 1 hour is 60 minutes. 60 minutes times 60 seconds, so 3600, and basically this is going to give us 1000 divided by 3600 meter per second. And we can get rid of all the zeros, and what we're going to get is 1 over 3.6 meter per second. So we can do the unit conversion here. So kilometer per hour we have in here. So if you just want to do the unit conversion, we just need to divide this by 3.6 meter per second. So again, this is 1 kilometer per hour, and I just switched this with this. So that's why I'm dividing 100 by 3.6. So, and also we know this is also to the power of 2, and this will be equal to 2ax s minus, so this is going to be 0, our s is 50 meters, and now we're consistent with all the units. And here we can find ax, it's going to be negative, and we have basically 100 divided by 3.6 squared over 100. So let's just calculate this. 100 divided by 3.6 and to the power of 2, and in the denominator we're gonna have 100, so this is gonna give us 7.72. So negative 7.72 meter per square second. So now that we have the acceleration, the question is asking us what's the force on each wheel. So if, let's say, this is our car and it has 4 wheels, so we're gonna have a total of 4 F forces on each of them, one in the front, one in the back. So we can consider just 4F force in this direction, and that's pretty much all the forces that we have. We have sum of all forces in x equal to mass times acceleration, and we can see that the force is actually in the opposite direction, which based on the Newton's law, the force and acceleration has to be in the same direction. So negative 4F is equal to the mass, which the question is giving us 1500 kilogram, times the acceleration negative 7.72, and this is going to give us the force F. So basically this times 1500 divided by 4, and this is going to give us 2893.5 newtons, and the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.